Hey, what's up, people? All right, we're here. Let's do it. 10:42. 12 minutes late. Not cool. Not cool. All right, so what are we doing today? What was that? Like, did my keyboard just turn into a musical keyboard? Um. Anyway, yeah. So we started implementing the coding to client refactor, the database that is. We finished up. We didn't completely finish it. We took a break. I was like tired of doing SQLite testing. I get like short attention span, I'm like, man, this is enough learning. I want to do some applying my knowledge real quick. So we took a break from learning more about the database, SQLite language, and actually began implementation of the database into client refactor into the project. We stopped at line 352, so let's go over there. So we tested what we added. It seems to be working. We stage committed. Okay, cool. So we were over here. There we go. Stopped here. All right. So this is where we had stopped. Let's go to our extensions and restart them. That's gonna make sure that they work. And I'll go ahead and since I'm like fresh, I'm gonna go back to this SQLite test real quick, and we're gonna test it. we're gonna do a little bit more. Bring this down to 50 because it's a little loud in my ears there. All right, so we have. Let's see, what do we want to test? Let's see. Let's go down here. What haven't we tested? Okay, let's go ahead and do constraint. Yeah, let's do constraint here. So we're gonna say constraint testing. Okay, so to test constraint, we're gonna create a table called employees. We're gonna have the ID as the integer, primary key, email as text, employee ID is text, department, and then constraint unique email emp ID. So it's a combination of the email and the employee ID. A not a combination, like it checks both of those. So it's gonna check the email and the employee ID, and we have this name for that checking, and it's called the unique email employee ID. So it's making sure that the email and the employee ID are unique. Therefore, we have the unique keyword, and this is a constraint. So this is now like a rule that we have to follow. We cannot have any row in the database wherein the email and employee ID together are the same. So we can have same emails. We can have 2 entries with the same email. We can have 2 entries or 10 entries with the same employee ID, but we can only have 1 entry with the same email and employee ID. So they might have, that doesn't really make sense in real world application, but it's just for example purposes. So let's go ahead and create that table. So we actually have to say cursor dot execute, and here we go. So create table employees ID, integer text primary key, email text, employee ID text, department text, constraint, unique email imp ID, and then we have the unique keyword email employee ID. And I want to rewrite this because why do I feel like what's wrong here? Oh, triple quotes. True. It's got to be tripled up, baby. It's got to be tripled up, baby. I feel like what's wrong? Don't you love when you go to bed on time? You're gonna get like 9 hours or 8.5 hours of sleep, and you fall asleep on time, and then you wake up at 2 in the morning for no reason. You can't fall back asleep till 4 in the morning. So then instead of getting your 8.5 hours, well, guess what, bitch? You only get 6.5 now. So then you're fucking tired all day. And it's like, man, what happened, dude? Well, why? In the morning? Don't you just love that shit, dude? Okay, here we go. So we have constraint testing, create table employees, ID, integer, primary key, email, text. Alright, yeah, so this should all be correct. But we're gonna need to... Okay, so to test this, we're gonna have to also do a cursor execute, and we're gonna do insert into what's this? Insert into employees. Value, was it values? See, I can't even remember. That means that, yeah, see that's, I'm new to this, okay? Insert into save data, let me copy this. Go back, alright, so. I had to give my little cheat sheet here. Insert into table name. Okay, so I had that right. And then we say, well, that's, you don't have to pass that in. We can just say values, and then we don't even have to use placeholders because we know the data is trusted. So we're gonna say, we don't even need to do on conflict or do update. We just say insert into employee values, and yeah, there we go. Then we say ID. So the ID is gonna be, and I think it needs to be a tuple. Yeah, so we'll say ID would be 1. Email will be jk7@gmail.com. And then, and that's a text, so it needs to be written as text. And okay, we have to use double quotes here because we're using single quotes for the method call string, whatever you call that. Then we have the employee ID, and we'll just say that's going to be 1, 2, 3, 4, and that's actually supposed to be. Well, no, they said it's text, so this actually is a string. Then this one will be department, and he'll be in the IT department, and yeah, there we go. So now we have the ID as 1, the email jk7@gmail.com as text. Oh yeah, we have to use double quotes too for all. That's why it was keyed up the coloring of the syntax. So then it's comma 1, 2, 3, 4 for the employee ID as text, and then department is IT, and we'll just capital. So it's more there. Yeah, and then this constraint isn't actually a separate column, it is just a rule. So now what we're gonna do is we're gonna insert into employee um, a new, we're gonna add a new employee, and this is gonna be a different ID because the ID is a primary key, so it has to be different. Primary keys have to be unique. So just like we use the unique keyword here, primary key implicitly demands uniqueness. So for this first one, we couldn't use 1 again. That would throw an error. So we use 2 for the ID. Then the email can be the same. We have the unique constraint for unique employee ID, which is email and employee ID. So this one will have the same email as the previous one, but we'll have a different employee ID. This one, his employee ID will be 421, but he's also going to be in IT. But, and that should work because the email is the same, the ID is the same, but the the ID is different. So it's fine. The email is the same, but the ID is different, and those two combined are different than these two. But if we make a third one, and in this one we use the same email as the previous, and then well, yeah, we'll just do it like that. Now we have the same ID, employee ID, and email, so they're both the same, exactly the same. These two columns for each row, these two columns in each of these rows are going to be exactly the same, and we have to change this to be a 3, otherwise that will throw an error. But now let's run it and see what output we get. So we will Control F5 this, which should work. Okay. Right. Create table in 150. I think I messed up some syntax up here. Unrecognized token, double quotes. Let me see something. What is the problem here? Create table if not exists. Save data, object name. Oh, wait, I did this wrong. Hold up. I think I had it wrong in multiple ways. Let me see. Oh, and we create this. Let's disable that one. Line 159. Line 159. Alright. So I messed this up here, guys. Let's fix this. So it's triple quotes. Tab that in. Create table. Table name. ID. Integer primary key. Okay, that's fine. Then we do email text. That's fine. Employee ID text. That's fine. Department. Yeah, all this is fine. This is the issue right here. That. Okay, so now I have to put another right here. I think there was two issues. Yeah. Okay, yeah. Okay, cool. So we fixed this. We had an extra quotation. I want to see, is this parenthesis fire? Okay, table employees already exist, so we have to delete the save file because it technically already existed because it was already in the database. Cursor execute 150. It says incomplete input. Yeah, so we do have to have this closing parentheses. The right here. So it goes cursor execute, and if you're gonna have multi-line, you do open parentheses, triple quotes, and then you hit enter. This is just for syntax. You don't have to do this, but then you indent one level, and you do create table, table name, space, open parentheses, and now this is all of your columns in the table. So you have your create table, table name, open parentheses, and then you indent all of the subsequent columns and give the name, the type, the name, the type, the name, the type, all separated by comma, and then constraint is also at the same indent level, I would say, yeah, for sure. And then at the indent level of the create table right here, you do your close parentheses, which ends off your column section, and then you do enter one more time at the base indent level and do your triple quotes, close parentheses to finish off that method call, the execute method call. So we ran that code, and the error that we get back is SQLite 3 operational error, which is incomplete input. That was because we didn't have that last parenthesis. But if we rerun it now, it will not let us complete this run of the file, because at line 170 right here, it says that we have a SQLite 3 integrity error where unique constraint failed. Employees email, employees employee ID. So you can see that we have the same email and employee ID as the above. It's exactly the same. It did throw the error here at line 169 because the previous entry had the same email but a different employee ID. And like we said, it's a combination uniqueness. So it's those two together have to be unique. Independently, they can be same. If that makes sense. And yeah, so if we were to change this to be 4232, or let's leave this the same. If we were to just change the email to be JK73 instead of JK7, but it still has the same employee ID, we'll see that it's gonna throw an error because we forgot to delete this database file, because now that table already existed. But since we have deleted it, now we're gonna rerun it. There you go. Yeah, everything works fine. But then if you make a new entry and you have jk73 at gmail 4321 again, now you're gonna get this error. You're gonna get the wrong error. You're gonna get an error nonetheless. Now we get the error that we were looking for, which is the unique constraint failed employee's ID. That's because the ID here is different. Okay? Oh, actually, you know what it is? It's actually the ID, because I forgot to change this to 4. So if this is 4, now you're going to get the correct error. Again, Here we go. SQLite 3 integrity error, unique constraint failed. Employee's ID emails employee ID. So it shows both of these because that's what has to be unique. Both of them together. And as you can see, this is the same as that, therefore it's not unique. So we understand that. Easy money, right? And we can just change this to insert big data and let me just make this a little here to well, no, this is fine because we want to have the constraint keyword. I don't know if we could use the constraint like elsewhere outside of a create table command, but yeah, I'll actually just leave it like this. This is fine, there's no big deal. And then we'll put throws error at this line due to email and the ID being not unique. Okay. Administration. Oh, yeah, we put that for. Okay, cool. So we tested that. Go ahead and comment this out. Alright, now we have the next one we're going to test, which is called the unique. Oh, yeah, we forgot to set our timer. We're 22 in, so that means we're 46 left to go. So let's go up to 46. And God, I'm so tired. Fucking hate being this tired, man. Like, I went to bed on time and everything. Just woke up at 2 o'clock. Because, you know, trying to wean off my sleeping medicine. Because I don't want to take it. It's not good for me. It just makes me, like, sleepier in the day. I know it does. So I'm trying to wean off of it. And means not sleeping as good while I'm weaning off of it, so had to pay the price. That's what happens when you get addicted to anything. When you get off of it, it's hard. Your body wants it and will fight you for it. All right, so the next one is going to be the unique keyword. Well, we basically just test the unique. I guess, yeah, we'll again, whatever. So now we'll just put unique testing here. And we're gonna add in a test for unique, and we'll do basically the same thing. We just did, we'll do cursor, execute, and then we're gonna do triple quote, enter, and it's up here, finish off this triple quotes, go back up here, and then we'll create table. And we'll say 6, and then to have close parentheses right there, in, and we're gonna give it the ID, integer, array key, and then we'll comma, and then this next one will be the is 7. And this will be, we'll make this a boolean. Then we'll have to say unique. And there we go. So that should do it. That's going to create the table 6. It's going to have the ID column and the is7 column. And now we're going to go right here and we'll try to do cursor, execute, and then we're gonna do insert into 6 values, and we'll just say 1. Well, I have to do it as a tuple. We say 1 and false, because 6 is patently is not 7, right? Okay.
When spring comes, I'm leaving town. I'm going to Midgar.
Let's go to Midgar, baby. All right, so now we do 2, and we're gonna say false again because you know it's 6 is not 7, right? Like hey, or the ID, you can say whatever, is not is it 7? False. All right, so now let's run this code and see. Well, first of all, let's delete the database because I know that's probably gonna. Actually, that I don't know. It might cause us an error. Okay, unique constraint failed. 6 dot is 7 at line 174. So you can see we got a constraint error here. So this is the same thing as like the above constraint, except it's based off of the unique keyword. It's actually the exact same error type. It's a SQLite 3 integrity error, unique constraint failed. Same as the above section, and it's exactly the same. The only different parameters, that was because these 2 parameters, it's the same exact error out. So the reason is because this Boolean entry has to be unique. So we could do true, and now when we run it, we have to delete the database file first, and there you go, no errors. Because then if we do false here and we run it, oh, it's gonna throw the error because the table already exists, and I'm an idiot and I do this every time. But now we're gonna run it again. There we go, unique constraint failed. 6 is 7 at line 175. Throws error at this line due to is 7 non-uniqueness. Due to is 7 boolean. Alright, there we go. So we tested unique. That's pretty easy. So let's comment these out. Now we have that one just we took care of. So this is going to be fetch many. So we'll do fetch many testing. And we'll do cursor dot fetch many. And this one I haven't used. What is fetch many? Let's let autocomplete tell me. Let's see. Fetch many. Size integer. None equals 1. And it's got to be a list. It's going to return a list of any type. It's got to be a certain size. That's a parameter. And I guess that means it don't pass any, or if you say none, it defaults to 1. I don't know what this means, this syntax of this descriptor, whatever you call this. But anyway, let's figure out how do we use this, because that's something I don't actually know how to do. So let's ask Claude. SQLite 3 fetch. So let's see, how do we use fetch many? So it's going to explain how fetch many works in SQLite 3. With Python, the fetch many takes in a parameter called size, and the method is used to fetch a specified number of rows from a query result set. Specified number of rows. Here's how to use it. Import SQLite 3, so we have the database, the cursor, then we say select all from users, and then we're going to do rows equals cursor fetch many, and then we're going to pass 5. So this will return only 5 values. Let's say there's 20 in the users table. 20 rows, that is. Well, it's only going to fetch the first 5 rows, but the order is not going to be dictated. Something to remember with database, the order is like randomized basically. It's not necessarily the order that you inserted into the database. It's how it's going to be fetched. So if you inserted it in alphabetical order, it's not necessarily going to be fetched in that way. So you might think, oh, it's going to fetch the first 5 starting at A, then going down to B. It's not. It can start at B, it can start at Z. It doesn't. It's basically random as far as I understand. Key points about fetch many. By default, if no size is specified, it uses the cursor's array size property. So if you say fetch many with no parameter, then default is usually 1. That is, I guess, what that descriptor was telling me. Defaults, none defaults to 1. And then cursor.array size equals 10. So you can change the default fetch size by assigning cursor.array size or fetch many. Okay, if there are fewer rows available than requested, it returns all remaining rows. If only 3 rows are left but requesting 5, it returns just those 3 rows. Okay, cool. And then once all rows are fetched, it returns an empty list. So if there's nothing to be, there are no rows left, try to fetch many, return an empty list. This method is particularly useful when dealing with large result sets where you want to process rows in batches rather than loading everything into memory. Dealing with large result sets where you want to process rows in batches rather than loading everything. Okay, now that's pretty straightforward. So you do select all from table and then rows equals cursor fetch many and then whatever number. So let's say fetch many 4, and then we're gonna do, we'll create this table here. Actually, we'll just use this table without, creating it. We'll just enable it, and now we're going to also have these 2, so we have 2 rows in the table, and then we're gonna do fetch many 4. And let's see what we get when we run this. But we actually need to delete this database file first, otherwise it's going to throw an error because that table already exists. So let's run this, and there we go. Everything. Oh, well, we have to print it, so we need to say print, because it just grabbed them, but it doesn't print them. Now we have to save the database file again. Now we're going to run it. And there you go, you get an empty list because, well, we should have got, oh, I didn't select. Yeah, I have to select first. So we need to say cursor dot execute, and then we need to say select from 6 select from 6 value we want to collect the, say, boolean. You're playing. Okay, select from 6 value boolean where ID is equal to, or ID, we'll just say ID equals, and then we have to pass in, that's not right. refresh my memory on the syntax here. Select, oh, that's right. So we say select all 6 from 6 value. No, we don't use value. We just say from 6 where ID equals we don't have to use the placeholder, I don't think. So if we run this, well, the table already exists because we didn't delete the file as usual. Okay, now when we run it, there you go. We selected, or yeah, we selected all of the rows from the 6 table where the I is equal to 1, and there's only one value there, and we're selecting all the columns associated with this. So this gets insert into 6 value, select all from 6 where ID is equal to 1. So it grabs this one, and then it returns 0 because that is the rest of the wait, why would it get 1 and then 0? Oh, because it's not ordered. So it's actually grabbing this because 1 is grabbing all from 6. Oh, no. Okay, I see what it's doing. It's selecting all the rows from the 6 table where ID is equal to 1. So it's going to return this entire row. This row consists of 1 and false. Therefore, it returns 1 and 0. So 1 and then false. If we were to have a third one, let's say, let's just duplicate this one. But then it's going to have 3, okay, none, and maybe that'll work, or null. It might require null. So delete this file first. No such column name, no. Okay, that's because we're only grabbing one ID. So we'll say, how about this? We just do grab all from 6. Make it real simple. So we're gonna grab all from 6. So it should grab 1 and 2, but it's gonna throw the error because the table exists. Now we're gonna rerun it. There you go. We get both of them. Tried to fetch 4, but there was only 2. There was only this row and then this row. So change this, fetch many to 1. Delete this database file, rerun it. There we go. Now it's only going to select this first one. Change it to 2. It will grab both of them. Just rerun it. There you go. And then if we do 3, it's still going to grab both of them. It'll change because it can only grab the remaining rows, and there's only 2 remaining rows. There we go. Now, if we have nothing in the table, if it's completely empty, then we can do select all from 6, and I believe that this will return a list. There we go. So since there were no rows returned, it returns an empty list instead when we do fetch. It tries to fetch 3 rows, but there's 0 rows because we disabled them. Yeah. And we'll just say if no rows left returns empty list, else if rows left less than or equal to num pass to fetch many. Returns tuple of remaining rows. Easy. Okay, there we go. So we tested unique, we got that going. We tested fetch many. Okay, so that one's done. And now let's do fetch all. Cursor execute, select all from 6. So now, okay, we don't need that. Change this to fetch all. And since we're only going to have 2 when we run this, it should, there we go, return a list of the 2 tuples, 2 rows. So fetch all returns a list. Just like fetch many and fetch all return a list. Yes, both fetch many and fetch all return a list of tuples, where each tuple represents 1 row. Returns list of tuples, each tuple representing 1 row. So this is exactly the same for both of them. Okay, so now we're gonna do foreign key. Dude, I'm so tired. I'm like literally have to take some caffeine like right now. I gotta go to the gym in 23 minutes and I'm just like, oh my god, I'm dying right now. I wouldn't be able to sleep. Like I guarantee you though, even if I lay down, I wouldn't be able to sleep. I can't take naps anymore. I just don't fall asleep. And I'm not taking sleeping medicine in the day. So I'm gonna get right. I just gotta keep weaning down off of the sleeping medicine, so that less of it will help me to sleep, so that it doesn't carry over and make me tired the next day. Because I think that's what's happening. Is it's through peak season, I started taking more of it, and since I was working so many more hours, I needed to make sure I got my sleep. I wasn't really worried about being addicted as much, you know. Now that I'm out of peak season, going back down, and get, you know, in my body, so that I can do less medication. A normal person doesn't take sleeping medicine. Once upon a time, I never had to take sleeping medicine. Yeah. All right, there we go. Catch. Caffeine should be hitting me soon. Should carry me through the day. All right, foreign key testing. Let's do this. Let's go over here. That I really don't know about. So let's foreign. So let Claude explain this to me. So let me explain SQLite foreign key support. First, you need to enable foreign key support as it's disabled by default. So we would have to do conexecute pragma foreign keys on, and then basic foreign key syntax when creating tables is create table users ID. Okay, where's? Okay, so we create one table user, then we create another table called orders, and we use foreign key user ID. Call it user ID. No. We're referencing this user ID from orders table. Got a tuple. Saying references users table at ID. So this is connecting this user ID orders table will link to the associated ID value users table. So if our user ID here is 7, we have a row wherein the ID is 7. Huh? Yeah, I'm here. But you need me? Hold up a second. All right, we're back. We're back. Okay. So we have to enable the foreign key first by using pragma foreign keys equals on. Yeah, and then we use the foreign key keyword in the table that has the column that we're going to use to refer to the other table's column. So I guess this is gonna link together. Now I don't know if that means this table is gonna have access to the other columns in users associated with that ID, the foreign key, but I guess it'll tell us that. Then it says 3, you specify what happens on delete update. So if you do foreign key user ID references user ID, and then you say on delete cascade, on update cascade, what does this do? Or you can do set null, set default, or restrict, and it will say common gotchas. Foreign keys must reference primary key or unique columns. So a foreign key has to reference a primary key or a unique column. And then that makes sense because it's going to refer to it, and it can't refer to multiple, I guess, or that's not allowed. And then the reference and referencing columns must have the same data type. Okay, that makes sense, obviously, because then it wouldn't be the same, right? Like, how would it reference it if it's not the same? How can it match if it doesn't match types? And then SQLite only enforces foreign keys if they're enabled. Okay, got you. So I guess you could use this keyword and it wouldn't throw an error or whatever, but it wouldn't actually work because you didn't pragma enable them. And then so I'm gonna show you how to verify if foreign keys are working correctly. No, but does the foreign key okay, explain more how they work, because that was not the best. I need a little bit. Read down how foreign keys work. Like foreign key creates a link between two tables by referencing the primary key or unique column of another table. Here's a practical example. Departments has department ID and it's the primary key, and then the child table is called employees, and so we call this a parent and child table. So the one that uses the foreign key keyword that creates the reference is the child table. So then we have employees, employee ID, name, department ID. So you can see the department ID is going to be the same. So then we're going to say foreign key department ID. So it's going to use this department ID, link, aka references, departments table here, and at that department ID. So it's going to match these two columns. I guess we'll have access to, you know, the rest of the data associated with that column, the table. Okay, when you have this relationship, you can do insert rules. So insert into departments 1 engineering, and then insert into, so we're going to insert into the parent table 1 and engineering, so that the department ID is 1 and then the department name is engineering, and then we're going to insert into employees 1 for the employee ID, Alice as the name, and then 1 as the department ID. So this is 1 and 1, but then we say insert into employees values 2 Bob 999. Oh, it shows it throws an error. Okay, so it has to exist in the parent table. If you make a column a foreign key, that means there has to be an associated row in the parent table for you to insert that data into the child table. So if there is no 999 row, a row with the department name of not department ID rather of 999, then it will not. If that doesn't exist in departments, then you will not be able to add it to the employees table. So it's a parent-child relationship. That's probably the most important thing to remember, is that the parent has to have a row with that foreign key for you to reference it, or for you to insert it into the child table. So only if there's department ID 1, 2, 3, 4 in the departments table, since it's the parent and we have the foreign key set up in the employees table, you could only insert data associated with the 1, 2, 3, 4 department ID. If you tried to enter in a row into the employees table that had a department ID of 5, but departments did not have a row with a department 5 entry, it would not allow you to do this. It wouldn't let you do that. And then we have the delete options. So on delete cascade, what does this mean? I don't know. On delete cascade, let's see, foreign key, department ID, references department ID on delete cascade. So previously we just said foreign key, department ID references departments at department ID, but we didn't have any suffix. But this has the suffix on delete cascade, so this is dictating what's going to happen when you delete something associated with this foreign key. So it says if you delete a department, all employees in that department are also deleted. So now in this case, if you had let's see, so you have the parent table departments, child table employees. If this was foreign key, department ID, references department ID on delete cascade, then if you deleted from, I guess, from either table, like if you deleted the department ID from departments, or if you deleted it from employees, it would delete the associated row in the other table. So if you deleted this row in this table associated with that department ID foreign key, then it would also delete the associated row from the department table. I feel like I'm not understanding that completely. And then it says on delete set null, foreign key department ID references set null. If you delete a department, all employees department ID becomes null. If you delete a department, so I'm guessing this means if you delete from the department table at this department ID, it's going to also delete the employees, aka rows, I'm guessing, from the employees table associated with that department ID foreign key. And same thing here, if you delete a department at a department ID, the associated apartment employees at that employee ID foreign key, their row will not be deleted. But their department ID will be set to null. And then on delete restrict, that will disallow you from deleting the department if it has employees. So if there are employee rows in the employee table, then that will disallow you from deleting the department, I guess, in both tables. So let me clarify this. On delete cascade, does this mean if you delete from either table, it will remove the associated rows, or only from the department table? Only when you delete from the parent table. Got you. So when you delete from the parent table, the cascade flows in one direction, from parent to child. Gotcha. So if you delete from departments where department ID is equal to 1, it deletes the department and all employees in that department. So then it's going to also delete from employees where department ID is equal to 1. But when you do delete from employees, since it's the child table where department ID is equal to 1, this is permitted, but it only deletes the it only deletes the data from the employees table. It doesn't cascade to the parent. Got you. That makes sense. Okay, now the foreign key relationship is one way. The child employee knows about its parent department, but the parent doesn't know about its children. Think of it like a family tree going only upwards. You know your parents, but the database doesn't track downwards to know all the children. Okay, yeah, that's cool. That makes sense. And then, so with that principle, let's try to see if we can understand this a little better. That being the set null. So this means, yeah, it only goes from parent to child. So this means if we delete a department from the parent, the child's department ID associated with that department ID will become null. Okay. And then when we use restrict from the parent, if we try to delete the employee, the department ID rather, it won't let us as long as there are rows in the associated child table with that department ID. Do you understand this correctly? So on delete restrict only allows to delete from parent table if no rows at associated foreign key exist in child table. I say exactly. Ooh, I told you. Bet. Prompt God. Exactly right. On delete restrict prevents deleting from the parent table if there are any matching foreign key rows in the child table. So victory, that's right. Child table departments, department ID, integer, primary key, department name, text. Create table employees, employee ID. Okay, we got all that. And then foreign keys, department ID, references, departments, department ID on delete restrict. So we insert into departments 1 and then engineering, and then so it's the same scenario as before. But if you try to delete from the departments where department ID is equal to 1, it won't let you because we have Alice as an employee in that department. So it just won't let you do it. But it would work, but you need to delete the employee first. So if you delete it from the employee where the department ID is equal to 1. So if you deleted Alice from employees, now there's no rows associated with department ID number 1, and then you can do delete from departments where department ID is equal to 1. Restrict is actually the default behavior in SQLite. If you don't specify an on delete clause, it helps prevent accidentally deleting data that's still being referenced. Okay, so and restrict is actually default. Okay. All right, well let's do this real quick. We got 1 more minute. Let's try to try. I'm so tired though, but I'm just gonna caffeine my way through this day. And then, God, I hope tonight I fall asleep on time, and actually stay awake. See, night before last, it was it was different. I couldn't fall asleep at first, but then when I fell asleep, I slept all the way through. But I lost like an hour and a half of sleep before I fell asleep. This time, I fell asleep on time, but I lost an hour and a half by waking up before I was supposed to wake up, before I needed to wake up. So both days, instead of getting 8.5 hours of sleep, I got like barely 7. Like last night I got like maybe 7. The night before last I got like 6.5. Not very great. Not when you're a heavy, hard worker like me, and you might have like a touch of old people disorder that makes you get a little more tired. It's probably just working out really hard. That makes me that tired though. But anyway, so let's do foreign key. Time's actually up. Timer's going to be going off in a second, but let's do this real quick. So we're going to create what we have to do: cursor, execute, and then we're going to do triple quotes, and then we go to the middle. Bam, there we go. That's easier. Then we do enter, tab, create table, and we'll make this departments, and then we're gonna do department ID, and this is gonna be integer primary key, okay, comma, and then we're gonna have the department name, and that's gonna be text. There we go. Now we go down here and we do cursor.execute, and we're going to insert into well, we want to create another table, so we'll create another table, and I'll write this out instead of copying because I want to learn the syntax. So we'll do 1 2 3 4 5 6 1 2 3 enter, go up here, enter, tab, create table, and this one's going to be called employees, enter, and oops, I forgot my parentheses there. Bring this back here. Now this is going to be employee ID, integer primary key, comma, name, text, comma, and then department ID, integer, and then we're going to say foreign key department ID has to be in a tuple for whatever reason, I suppose, and then we say references, because I guess it could be a conglomeration of multiple different columns, maybe, I don't know, I guess, maybe, departments, and then we're going to do department ID. Okay, so this is the foreign key, and we're referencing our column called department ID, and it references the departments column at department ID, which is the same name. And then it doesn't have to be the same name, it could be a different name. They don't have to have the same name for the title of the column. And then we say on, delete, restrict, which is actually the default behavior, so we don't have to designate that. There we go. So we now have 2 tables, and we're going to insert into departments values, and we're going to pass in 1, and then engineering, and it needs to be double quotes, and we'll just say IT to make it a little faster. There you go. And then we're going to insert into employees. Employees. 1. Then we need to enter in her name, Alice. Alive. Alive is just as good. Alice is alive. And then the department ID will be 1 as well. There we go. So it's going to link this to this, and there we go. Now, insert into department values 1 IT, insert into employees value 1 alive, 1, and now if we try to do cursor execute, and we're going to say delete delete from departments, because remember we say on delete restrict, so it's not going to allow us to delete from the departments table while there are employees in the employee table at that associated department ID. And since we do, we have alive at that ID of 1. When we try to delete from departments where department ID is equal to 1, it's not. Well, let's try this. Let's try it this way. We'll reference it using not the foreign key. We'll say where name. We'll use a different column. We'll use name. We'll say where name is equal to alive. So even then, I don't think it'll let us delete this row because that foreign key is still connecting them. We don't have to reference that foreign key with the where statement. I don't think that is going to matter. I think it's still not going to let us do this because they're still connected through this constraint, this restriction here with the foreign key. So when we go to run this, actually need to disable this code here, so we don't need it, and this code as well. Okay, so let me go over here, delete this save file. Now let's run it. You know what? Run it. No such column name. Oh, right. I'm an idiot. Delete from employee. So we want to delete from the employees table where the name is equal to alive. Now it's going to throw an error because that table already exists and we didn't specify only created if it exists. But that's okay. We'll just rerun it. And there we go. It works. Wait. It's not supposed to work though. So maybe you do have to. Oh, right. Okay. So it will let us delete from the child. Okay. So I actually can't do it that way. I wanted to. How about this? We'll say delete from departments where. And we'll just use, instead of the foreign key, which is department ID, we'll use department name. So the department name is IT. So let's see if it will let us delete this. Wait, I'm confused now. Okay, I'm an idiot. I got it wrong again. Hold up, let me review this. Prevents deleting from the parent table if there are any matching foreign key rows in the child table. Deleting from, so if you try to delete from departments where department ID is equal to 1. So is that the only difference? Is if we reference the department ID? So we do have to reference. I don't think that doesn't sound right. That doesn't sound right. Yeah, something ain't right here. Let's try this. What am I doing wrong here? Something's not right. Something's wrong here. It shouldn't let us do this based on what ChatGPT said. Why does it let me do this? Oh, this is coming. Gotcha. With SQL. Oh, I didn't enable foreign keys. See, that's a good. Yeah. That is. Man, I tell you, that's some sneaky shit right there. You see what I'm talking about? See what I'm talking about with programming? I feel like when you make a language like this, I don't know the details behind it. Maybe there's a reason, you know. Maybe there's a reason. But I'm wondering why do you not have an error handler for this scenario? Like, you shouldn't let me think that I'm using foreign keys. You know what I mean? It should explicitly tell me with an error. It should say, "Hey, you can't do this. You're referencing the foreign key keyword, but you don't have foreign keys enabled." You know, like, I guess it's it's like a feature. You can just turn them on or off like a switch. So you can like add the code, you know, and then they work if you turn the switch on. I guess if you look at it that way, that's fine and cool. It's just like, man, if you forget that, but you think that that's it's kind of a big deal, because then you're deleting shit that you probably think you're not deleting. Like, it's not gonna, you know, You're like, oh yeah, the foreign key is not going to let me delete it because I did on delete restrict, but you don't have the foreign key enabled. The pragma, the setting on the database doesn't have that enabled, so you actually can delete them, and you have been deleting them, and you doesn't tell you that. You have no idea until you go to look for the data, and you're like, hey, where's my data? Well, it's gone. What do you mean? Why would it not throw an error? So we forgot to add in the cursor execute pragma foreign keys on. So then we say cursor execute, and then we'll say pragma. How do we do this? Foreign keys equal on. Now let's run it. It's going to throw an error because that database exists. Because that table, rather. Redo it. There we go. Now we get our SQLite 3 integrity error, foreign key constraint failed. When we try to delete from departments where department ID is equal to 1. Okay, so now let's try to see if it works even when we reference it, that row, through different means. If we reference that row through the department name, will it still have that constraint? If we don't use the actual foreign key keyword, okay, it still won't let us do it. At line 208, it will not let me delete from this department where department name is IT, because the associated row with IT has that one foreign key. So the foreign key constraint disallows me from being able to delete the row, even if I try to delete it referencing the other column slash columns. If there were multiple, like whatever column, it doesn't matter what column I reference, as long as this foreign key is connecting the child and the parent, and I have the on delete restrict with the foreign keys pragma enabled, it will not let me delete any of those rows. So there we go. All right, now that we'll say method number 1 will not allow deletion since foreign key links parent to child. And then method number 2 is will not allow deletion even if referencing a different column other than foreign key. There we go. And so we can comment this out now. And now it's time to quit. It's time to go to the gym. I can feel the caffeine weaving its way through my tired bones and lighting a fire where there is none. And my body is like, why are you doing this to me? But I wouldn't have been able to take a nap anyway. I already know how that works. So we just have to do these last few. We're going to do references. We're going to do, so we'll say references test. And then we're going to do limit test. There we go. And then we'll do case test. Case test. There we go. So we have limit test, case test. Wait, why do we have this twice? Whatever. Select case. And there we go. Let's get rid of this. Alright, so let's copy. Oh, we'll just copy this. Oops. Then we'll go down. Do this again. Okay, and I gotta rename these. So this is gonna be when. This will be when. This one's gonna be order by. And then this one's gonna be then. Alright, and then else. And then we have add in comment test about diff between decimal slash float test. So we'll say decimal slash float test. So need to do test for all these. Okay. All right, there we go. So when we come back, we got to do references test, limit test, case test, when, order by, then, else, and a decimal slash float, float. All right, so that's it for now. So we're gonna go over here, write up our devlog. So we went 12:10. So we actually got it in, dude. We got it in. We did an hour and 28 minutes, which is basically an hour and 30, almost exactly an hour and a half. And what we did was we continued testing how to use SQLite and SQLite while prompt learning from, not from ChatGPT, but Claude on the process subject. There we go. All right, so we'll come back. We'll do more after the gym. And I had my camera disabled. It is what it is. Yeah, so we'll come back and we'll finish this. We'll do some more in a bit. All right, so see you guys in a while, and after the gym, we'll do